Good morning, children. So today we are with second chapter, and the name of our chapter is Number System and Introductions. First of all, let me tell you, computer is a machine. Machine understand only a number which consists of 0 or 1. That is binary. We human being, we understand decimal number, the number which contain 0 to 9. So based on this, the number systems are categorized in 4 different parts. Number 1 is the binary. Number 2, decimal. Number 3, octal. Number 4, hexadecimal. So binary means number which have 0 and 1, that is 2. Decimal 0 to 9, that is 10. Octal 0 to 7, that is 8. And hexadecimal 0 to 9, then A to F. So total it contains 16 digits. So there are 4 different types of number system available in this world: binary number, decimal number, octal number, hexadecimal number. Now see, children, computer or any machine in this world, they understand the language of binary, that is 0 and 1, where 1 means on, 0 means off. Okay, but we people, we human being, we understand decimal. But there are some cases where we need to use octal and hexadecimal also. So when we use octal and hexadecimal, so these things should be, these three should be converted to binary part. Then only machine will understand and machine will execute. After execution, the machine gives us the information which is in decimal form. So there is a conversion of number required. Okay, so usually these two conversion is required: binary to decimal and decimal to binary. Now you might be thinking, what about octal and hexadecimal? So octal and hexadecimal are two exceptional number type which we need to convert to decimal, and decimal will be converted back to binary. Computer will execute, again it will give the information in the part of decimal, which will be reflected as octal or hexadecimal to user. So children, how many type of number system we have? 4 different type. What are they? Binary, decimal, octal, hexadecimal. Among this, the machine understand, that is binary. We human being understand, that is decimal. External, additional to this decimal, we have 2 more, octal and hexadecimal. So the conversion part, we have to know binary to decimal as well as decimal to binary. And one more thing we need to know, octal to decimal as well as hexadecimal to decimal. So children, see here. So now we'll learn how to convert the number from one type to another type. So see, first of all, decimal to binary conversion. How to convert the decimal number to binary number? So let us take one number, say 12. Now we need to convert this 12 to binary forms. So when we are converting, we'll take the help of LCM, but every time we'll do with 2, and we'll take the remainder here. So 2 6 are 12, remainder is 0. 2 3 are 6, again remainder is 0. 2 1 are 2, remainder is 1. And the arrow will be from down to up. So the binary part of 12 is how much? 1 1 0 0. So binary means it contains the number either 1 or 0. Okay, so whenever any decimal number is there, if that should be converted to binary, we have to use this logic. Okay, this is a very important logic and very simple also. Very simple mathematical calculation is there. The LCM part, okay, and some division concept we have to use. Every time we have to do with 2, and the remainder we have to store side by side. And when at last you get either 1 or 0, you have to stop your calculations. And the arrow movement, see, from down I have taken and I have moved to upwards. So 1 1 0 0. You cannot even tell 1100. That is also wrong. You have to tell 1 1 0 0. This is binary part. Is this clear, children? Now see the another conversions. So children, now just opposite of this one, that is binary to decimal conversions. So when we convert binary number to decimal numbers, so let us take the same example of binary, that is 1100, and let us convert this one to decimal forms. So when we convert this one to decimal form, so first of all I'm just separating the numbers of binary. Just place the 2 below down, put the power from this side 0 1 2 3, multiply with the above number, use plus sign. I'm just taking in the bracket this one. Now use the calculation. 2 to the power 3 is 8, 2 to the 2 is 4, this is 0, this is 0. So finally how much you get? 8 plus 4, that is 12. You can see this one is the decimal form. Just now I have converted 12 to 1100, that was decimal to binary, okay, with LCM process. Now when I used another process, means just reverse one, so what I did is binary I have converted back to decimal, and you can see the answer is correct. Both answers are same. Okay, so children, you understood how the computer and human being interact between the numbers. So there is some conversion, some programming technique are used. Okay, and the conversion technique is in the same way, this one which I wrote here. So children, now next we'll move, that is we'll learn how to convert octal to decimal as well as hexadecimal to octal. Okay, up to this much is clear. Now see the next. So see the next, that is octal to decimal. So children, how octal numbers are converted to decimal forms? Let us take one example, 2416, 2416. Let us take this one as octal because it has all the digits between 0 to 7. Okay, now to convert this one, see some logic is there. Octal means how many numbers? 0 to 7, that is 8. So we have to calculate with 8. Okay, so we'll take this one first. So 6 into 8 to the power 0, 1 into 8 to the power 1, 4 into 8 to the power 2, 2 into 8 to the power 3. So any number to the power 0 is how much? 1. So 1 into 6 becomes 6. 8 into 1, 8. 8, 8, 64. Isn't it? 64 into 4, 256. And 8 to the power 3 into 2 becomes 1024. So when you do sum up, you'll add this all, you'll get 1294. 1294, and this number is known as the decimal number. So children, understood how octals are converted to decimal? Whatever may be the octal number, it should be in between 0 to 8. Okay, that means 0 to 7, that means 8. 0 to 7, 8. Okay, so here 2 between 0 to 7, 4, 0 to 7, 1, 0 to 7, 6, 0 to 7. So it is octal. Just take the numbers, use 8 to the power 0, 1, 2, 3, multiply with the numbers given. Okay, just sum up, you will get the result. In the same way, children, we can convert hexadecimal to decimal also. So children, see here, hexadecimal to decimal conversions. In the same way as how I did for octal to decimal, we have to do for hexadecimal to decimal. So let us take one hexadecimal example, that is 3b, and if you do in the same process 3b, let us take b into 16, because hexadecimal means 16 to the power 0, and here 3 into 16 to the power 1. Any number to the power 0 is how much? 1. So 1 into b. Now b is how much? 11. Okay, because a is 10. Here 16 into 3. 48. Okay. So now we'll do the sum of this one. So when you do sum of 8 plus 1 becomes 9, 4 plus 1 becomes 5. So this is your decimal part. So children, conversion of octal to decimal and hexadecimal to decimal are same. In the same way we have to convert. Rest, main important part is binary to decimal and decimal to binary. So is this clear, children? Okay. So now you'll get some homework. So children, the topic today I have covered is like the conversion of various number system. I have taught you how to convert binary number into decimal number as well as decimal number into binary number. These two are the most important conversion. So along with this, even I have taught you how to convert octal number to decimal number. In the same way, hexadecimal number to octal number, decimal number. So binary means 2, 0 and 1. Decimal means 10, 0 to 9. Octal means 8, 0 to 7. Hexadecimal means 16, that is 0 to 9 is the number, then A to F, that is alphabet. So A will be indicating as 10, B11, C12, D13, E14 and F15. 0 to 15 becomes 16 numbers. So based on this, I have given a piece of homework. There are 2 questions where you need to convert the number type from one to another. So see your first question. Convert the following binary number into decimal number. That means a binary number is given. Okay, the number which consists of 0 and 1 is given. Your work is to convert this number into decimal number. So how you will be converting? So for conversion of technique or for converting technique, you just see the video properly. Step is given there. Even I have did one example. The same way, the same example you can implement here to solve this, to convert this. There are 2 questions for conversion from binary number to decimal number. Same way you have question number 2, that is number B. Convert the following decimal number into binary number. That means in this you get a decimal number which consists of digit between 0 to 9. Your work is to convert this decimal number into its equivalent binary number. So how you will be converting again? See the video. The step is given, the process is given. One example I have did. In the same way you have to do this one. There are 2 questions again, 15 and 64. You need to convert. Binary, decimal, decimal, binary are most important conversion type. Reason, binary is understood by machine. That means whatever we feed to computer, we put or we input to computer, that we do in decimal form, and computer understand only binary form. So the conversion is required. So our input is converted into binary and machine understand. Machine process. After processing the result, it display as output to us, but we don't understand in binary form, we understand in decimal form. So again a conversion is required. So decimal, binary, binary, decimal conversion is very important to interact, to communicate with any computer or electronic device. So children, this is your homework.